Hello everybody, welcome to the third part of Chapter 2, Section 9, Applications of Percents. And what we're going to be looking at is just a few problems here on how to apply what we learned about proportions and equations to word problems. This is a pretty important piece for us, so take good notes, follow along, and bring me your questions. The first problem you have right here says George Bush was inaugurated as the 43rd President of the United States in 2001. Since Grover Cleveland was both the 22nd and the 24th presidents, there have been only 42 different presidents. Of the 42 presidents, 8 have died in office. What percent have died in office? Now this is from an older book, so we're just going to do the problem as it's written, even though there has been another president since then. Let's just go with this question for now, and we'll pretend there are only 42 presidents as of this date. All right. Well, we learned in the previous video, we learned about is over of is equal to percent over whole. Percent over 100, and we learned that that is the part, and of represents the whole. So what we want to do in these problems here is we want to make the connection. So on this first problem, I'm going to ask you to do a little bit more work in your notes and be prepared to show that to me. We're actually going to work this one out both ways, as a proportion and as an equation, and then on the rest of them I'll just kind of pick away, and as long as you can justify your work, if you use a proportion or an equation, I'm fine with that, unless I specifically ask you a certain way. As long as you can justify it through your work, we'll go with that. Well, let's say I want to use this proportion is over of equals percent over whole, or equals percent over 100. I can't say that today. All right. Well, to do that, what you have to do is you have to begin by identifying the part, the whole, and the percent, because you have basically 4 spots here, right? But one of them you know is always 100. So basically you need 2 of these parts, the is, the of, and the percent. You need 2 of those 3. So let's look at the information here, and let's start with to see if we can figure out what the part of this is. Well, in this particular question, it says there's 42 presidents, 8 have died in office. Okay, now think about that. There are 42 total, 8 of them have died in office. The question is asking you what percent have died in office. Look, before you get into problem solving and before you panic because you had to read a couple sentences, why don't you ask yourself the question, what am I trying to find? What is this question about? Understand the problem. This question wants you to find a percentage, and they want to know the percent of presidents that have died in office. Now, I know you could probably do this another way, but please focus on the path, how we're getting here for this. The part in this question is 8, because 8 of these presidents have died in the office. Okay, the whole is the total number of presidents. The whole is 42. Now the other piece we need to know is the percent, and that's what the question is asking. So that's your x. So from that information, we can set up this proportion. Part over whole, right here, 8 over 42 is equal to percent, that's the unknown, over 100. So look what you have. You have a proportion, and if you've done your work from yesterday, you should quickly be able to go through and solve this. 42x equals 800, and you divide that by both sides by 42, and you get this real small number. X equals 0.0525. Then to turn that into a percent, you multiply it times 100, so the answer is actually 5.25, and that's where you put on the percent sign. You put it on after you've converted the decimal into a percent. And then if you would divide the page in half, and then over here write the word equation with a line. All right, let's do the same problem, but let's see if we can write this as an equation. Well, the way that's easiest for me is to try to put it in the phrasing like the problems we saw from the previous day. Okay, what I want in the equation, I want a variable and then the other information. So here's what I'm thinking. I'm thinking, well, I want to know 8 basically is what percent of 42. Now, this is not the only way you could phrase this question, but based on the previous lesson, I can now translate using what we learned yesterday. 8, remember what is means? Equals what percent, remember that's x, of 42 means times 42. Now, how would you solve this? You divide by 42. Okay. X equals 8 divided by 42. What's that? 0.0525. Translate that to a percent, like we did in the previous side. You can see it's the same thing, 5.25%. Okay, so we're happy. We've done it both ways. Now in the rest of the notes, I'm just going to pick one way, but I challenge you. What I find honestly is that some questions I could just see as a proportion really easily. Some questions I could just see as an equation. But I've had a little bit more practice than you have, so take advantage of that, but there will be times I might ask you to show me one or the other. Let's work through a couple more. I don't know if we're going to get done with this in one video, but if it takes two, I think the second one will go pretty quick. This is the bottom one on the first page. Now this one, requires a little bit of thinking on your behalf. Take a moment and read it. It says a set of golf clubs costs $600. They're on sale for 40% off the regular price. Now, I believe that $600 is the regular price. Okay, don't tie up on whether that's the sale price. I don't think that's the sale price in this question. So we're going to say $600 is the price before the discount. What is the sale price of the clubs? Well, again, you can do this either way, but you have to justify the work. You have to have a variable in either whether you do the proportion or the equation. Okay, well, here's what I'm going to think. I'm going to think, well, the first thing I have to do is figure out what the discount. And I know that the discount is 40% of $600. Now the discount's not the answer. They're asking me for the sale price, but I can't find the sale price if I don't know the discount. Okay, the discount is unknown, so that's like X. That's equals, there it is, see it, is 40%, that's 4/10 of 600. That means multiply. All right, X equals 40% of 600. Multiply that out, I believe it's 240. Now that's not the answer though, is it? I hope you just said no, it's not. But you need that piece of information to get the answer. Okay, because to get that answer, you have to take the regular price, which is 600, and subtract the discount, because the question asks for the sale price. 600 minus 240, work that out. I believe it's 360. You can check my math on that. I'm pretty sure it's right. Now, I do want to show you another trick on this one. This is not another way. There is actually a faster way to do this. Okay. You could have thought this. I'll do a think bubble here. You could have thought to yourself, there's a big think bubble, because this is actually easier, and I know you probably like easier or faster, less writing. Right, 7th graders, I've known you long enough. You could think like this. Well, if 40% off the regular price would give me the sale price, I could also think the new price is equal to, if it's 40% off, then that means the new price is 60% of the regular price. See, think about that. If you're going to take off 40%, what's left? 60%. You're going to take off 40%. So what if instead I said X is the new price is equal to 60% of the original price? Multiply that out, see what you get. 360. So you did it in one step there. You didn't have to subtract it, because when you changed your percentage to whatever was left over from the 40, it gave you the sale price there. Because the sale price is 60% of the original price. Okay, that's a nice little trick for those problems. And I'm fine, as long as you justify it with the equation. Again, this is what algebra is. It's about writing equations. So don't just write down numbers without. I want variables, and I want you to get used to using variables to solve problems. It's what we're about in this class. Next slide on the back. No, it's 10 minutes. I'm going to stop and start another one, but we will do these faster because I'm just going to show you one way on each. So I'm going to stop here and I'll begin part 2 in a moment.